Let's continue talking about integrating rates of change. Remember the relationship, the derivative of a function like position is velocity, and of course that's the same as saying the antiderivative of velocity is position. Now last time we integrated a rate of change that was a constant to solve a differential equation. What I want to look at now is rates of change that are not constant, that are varying with time. Let me show you what I mean. Suppose water flows out of a container at the variable rate of square root of t liters per second from time t equals 0 to t equals 100 seconds. How much water in total flows out during this time? Notice that the rate of flow of the water is not constant. It depends on what time t you're looking. So for this problem, we really need an integral to find the total volume. Remember the idea from calculus that an integral is basically a sum. So the idea is we want to sum, an integral is shaped like an S because S stands for sum. We want to sum up all these flow rates in terms of square root of t liters per second times dt, which is in units of seconds. Notice that the units will cancel out here, giving us the volume that we want. Okay, that's kind of messy. Let's write the integral we really want. I want to integrate over the total time from 0 to 100 of the flow rate square root of t dt. So this integral exactly gives us the total volume. Now we just need to remember that the antiderivative of t to the 1/2 power is, let's see, t to the 3/2 power times 2/3. And we're using the fundamental theorem of calculus here to evaluate this integral. So let's plug in. The upper bound is 100 to the 3/2 power minus, well, the lower bound 0. 3/2 power is really telling you do the square root of this number, that's 10, and then cube it, that's 1,000. So my final answer here is 2,000 divided by 3. And remember the units are liters. That's the total volume that flows during this time. Now let's do one more thing. I'd also like to know, question, what is the average flow rate? Now we can also use the integral to answer this question. In fact, maybe you know that the average value of a function is given by this formula, 1 over b minus a, integral from a to b, f of x dx. That's the average value. So if I want to know the average value of the flow, then I integrate the flow from 0 to 100. And this term in front helps me do the average, so 1 over 100 minus 0. In fact, you'll notice that we've already solved this integral in the part above. So the average flow rate is 1 over 100 times 2,000 over 3. Let me cancel some zeros. I get 20 over 3. We divided by a time here, so my units are back to liters per second. So to summarize, we started with information about a flow rate in liters per second. We integrated it to get a volume. Total volume of flow was 2,000 over 3 liters. And then I could divide by a time again if I want to find the average flow rate, 20 over 3 liters per second. These are just some of the things you can do with integrating rates of change.